Logic 0, example 29.2, using conditional proof. So we're going to prove the same argument that we had in the previous example, but now we're going to use conditional proof. And so we have a problem that looks like this. And we want to prove this, and we're going to use conditional proof. And what a conditional proof is structured like, it's all based upon a supposition. Or you might think of the supposition as a hypothesis. And we're going to assume that is true conditionally. And on that condition, see what we can derive. And then in this case, if we suppose A and C, that's the antecedent of the conclusion that we want to derive, we're going to suppose that. So we're going to call this our supposition. We put that bar in front of the supposition to indicate that this is a conditional supposition, that we're only assuming it for the sake of argument as a condition. We haven't derived line 2. We've simply supposed it. Okay. So everything within this indentation is not derived, it's only supposed. All right. And then if we have A and C, we of course have A using simplification from line 2. And then if we have A, we can, and within the conditional proof segment that's sectioned off with these vertical bars, we can appeal to what is above the conditional proof segment. So we can appeal to line 1 and we can derive B from line 1 and 3 by modus ponens. And then when we have a structure where we have some supposition and then a statement that is derived under the conditionality of that supposition, the rule of conditional proof says that we can write this as something that we have derived. A and C only if B. And that's from lines 2 through 4 by conditional proof. And we're done. And notice that this is shorter than the previous version. So the previous version took 8 lines or 7 steps. This takes 5 lines or 4 steps. So using conditional proof, we get a superior proof.